Hello, today we're going to cover Business Calculus, section 5.1. So in this chapter, we take everything we learned in the first 4 chapters and turn it backwards. So we call this integration. Integration is the antiderivative. It's going backwards. So all of the same rules that we learned about taking derivatives and all those shortcuts still apply, but we're going to take them all backwards. So if you remember the rule when we were taking the derivative, we'd bring that power out front and we'd go down 1. So when we're taking the antiderivative, we bring the power out front and divide by it instead of multiply by it, and we go up 1. Now you'll notice in all of these formulas right here, we have this plus c. And the reason that that's included in every single antiderivative, no matter which formula we use, is because if you remember, the derivative of a constant is 0. So that means when you were taking the original derivative, you might have had the derivative of a constant and it would have just disappeared. So when we're integrating, we have to account for that possibility that there might have been a constant there that had then, of course, disappeared with the derivative. So this funny image right here hopefully will help you remember. I always throw in that plus c. It's easy to forget. You get stuck up in the math, so don't forget to add on that plus c. Okay, all right, so we're going to kind of follow these rules right here. If you have just a constant, then that constant would have been the one next to a single x, because the derivative of 5x was just 5. If you have an e to the x, if you remember, our derivative of e to the x was e to the x. So the same thing happens. It's still just that e to the x, but then we always have to tack on that plus c. So if there's more than just a single x involved, then we have to integrate that function next to it. So if there's a constant there, we can kind of pull it to the side out of our way, and then just follow these same examples that we've been doing the whole time. So of course, this all makes more sense when we get going. So let's give it a try. So if I wanted to take the antiderivative of f of x equals x to the 4th, then I would write it out like this with this little kind of long s-looking creature here. So the integral of x to the 4th. Now they always tack on this dx right here. And that's because as you get higher in math, it will be less obvious which variable we're integrating. So there are cases where we would have a variable that was not being integrated, and that would have been identified right here. So this right here seems pretty obvious for all of our problems, but it is important to write. So I would take the integral of this x function with respect to x is how this is written out. So we're going to follow this formula right here because this is x to the power of 4. So remember, the derivative goes down, the integral goes up. So up 1 from 4 is 5. And instead of multiplying like we did for the derivative, we divide. Let me write out all the steps for you here. And we divide by that one higher number. So the final answer will be x to the 5th over 5. And then don't forget that plus c. X to the 5th over 5 plus c. Now, if you're unsure, you're more comfortable taking derivatives at this point. So take the derivative of your answer, make sure it comes back out the same. So if I were taking the derivative, I'd pull that 1/5 out of my way. The derivative of x to the 5th is 5x to the 4th. And then the derivative of that constant would have been 0. And sure enough, those 5s would cancel, which gives me right back the x to the 4th. So it's just kind of a quick, easy way to check your answer, especially these first few times until you get more comfortable with the integrals. Okay, now this one, we've got that constant 8 there. So remember, we're just going to kind of pull him out of our way for now. So just look at the x to the 7th part, ignore the 8 for now. So we're going to do that same thing. 8's going to hang out over here waiting for us. So I'm going to go 1 higher than 7, which is 8. And that goes on the bottom as well. And don't forget the plus c. So then cleaning it up, those 8s would cancel. So the final answer to this problem would be x to the 8th plus c. If I were double checking the derivative of x to the 8th is 8x to the 7th. Okay, same idea here. I pull that 14 just kind of to the side. Don't worry about him right now. Focus on just the e to the x part. And if you remember, the derivative of e to the x is e to the x. Well, sure enough, the integral of e to the x is the same exact e to the x. The only thing that's different is we need to remember that plus c. Now this one's sneaky. It's just the integral of du. Notice it's not dx, it's du. So basically it's saying we're integrating the constant number 1. Okay, well, if it was the constant, that would have been just that constant next to that variable. But like I said, it's not an x this time, it was du. So the variable they're using is a u. And then of course the plus c. So the answer would be not 8x, it will count you wrong. 8u plus c, because it was a du. So that's one of the other examples of why we would need this right here. If it had not been specified right here, I wouldn't have known which letter to use. All right, so these were just one little term just to kind of get us started. But of course, usually there's a little bit more going on. So this one has 4 separate terms, but I just look at them one at a time. So I look at this guy and treat him exactly like I did over here, just looking at him one at a time. So the integral of 4e to the x, just like we saw right here, would be 4e to the x. Okay, it is plus c, but don't worry, we're going to tack that onto the very end of the whole thing. Okay, next we have 4x to the 4th. I'm going to pull this 4 just kind of to the side, till I'm ready for him. Integrate up. Derivative down, integrate up. Up 1 from 4 is 5. Okay, now this one's sneaky. Remember, we need to write it as a power. So this would be the same as minus 4x to the negative 5th. Okay, so again, I'm going to pull that minus 4 over to the side, ignore him for now, and then up 1 from negative 5, up 1. Negative 5 plus 1 would be negative 4. Okay, I'm going to write that out just to make sure you understand where it came from. So that negative 4 would go in the power and underneath. Okay. And then last, this constant, be careful, derivative goes away, but when you're integrating the constant, remember, just like that last one, he appears next to the variable. And then just one time for the whole thing, we'll tack on a plus c. Because if there had been more than one constant, I would have been able to combine those constants as like terms. So I just need 1 plus c for the whole thing. So let's clean this up a little bit. 4e to the x, that's as far as you can go. This one, I can't really combine them, but I could write it as the single fraction, 4x to the 5th over 5. Okay, this one, this would be a negative 4 on the bottom, so those would actually cancel out. But be careful, they don't cancel and disappear. They reduce to a positive 1. Okay. Okay, because this minus 5 plus 1 would be minus 4, and minus 4 over minus 4 is a positive 1. And then, of course, plus 4x plus c. Now, I'm pretty sure that the xyz was okay with this answer. There is kind of a technicality that in final answers, we should not include negative exponents. So just to be extra safe, I'm going to write out both versions of the answer. 4x to the 5th over 5. That would then be 1 over x to the 4th. Remember, once you flip it, no more flipper. Plus the 4x plus the c. Okay, so you should be good with that first circled answer there, but just in case it should count you wrong. Okay, this is another version of the same answer. All right, now this one, it looks like a huge mess, but don't worry, we just need to rewrite it as a power. So without integrating it, I'm just rearranging things. This is 6, and then this is x to the power of negative, because he was on the bottom, 7/4. Remember, roots in the ground, so the roots are the denominator of the power. Don't forget your dx there. Okay, so again, let's pull that 6 out of our way and just focus on this crazy power here. Don't worry, we got this. Okay, that's a 4. Sorry, my 4s sometimes stick together like that. There we go. Okay, so let's focus. The rule was to take it up 1. So let's just do it step at a time. So negative 7/4 plus 1. And then I can punch just that in my calculator and see what we got. Okay, negative 7/4 plus 1 is going to be negative 3/4. Okay. Now I can bring together the number part 6 divided by negative 3/4, but I do need to type it in carefully with parentheses. 6 divided by parentheses negative 3/4. Okay, that should then copy dot flip and give you a negative 8. Okay, 6 divided by the negative 3/4 makes negative 8. Now, again, remember, I could write it like this. I'm next to positive it takes it that way. But the technical, truly mathematical right answer with all of the technicalities would be to flip that flipper. Okay, oh, get that thing in my 4 again. And then of course, what do we need at the end? Don't forget that plus C. Okay, so notice I kind of waited till the very end. Technically, he appeared right here and was there for every step, but I was just focusing on cleaning up. So just tack them on right there at the very end. Don't forget your plus C. Okay, so it takes some practice, kind of get used to this going backwards because you're used to going forward. You're going to take it down instead of up a couple times. Don't get mad. Just keep doing those similar problems. And you got this. Okay, now there is a way that we can know what the specific C is. So if you remember, the derivative is the slope, and you can find the slope of a line at a tangent point, but the slope does not show specifically where the original function was, just how steep it was. So if they gave us one more piece of information, then I can work my way backwards to find exactly where it was and what that constant would have been. And so that's what we have here, one more piece of information. So it starts out and it says we're going to find the original function when we knew the derivative and a single point on the original graph. So we can go from that derivative backwards to get the original. The integral cancels the derivative. Okay, so this is my integral symbol. I know it looks like a sloppy S. The integral of the derivative is the original. Technically, that's the fundamental theorem of calculus. Okay, so let's try that out. What is the integral of 3x squared plus 10x minus 2 dx? Okay, step at a time. So 3x squared up 1 from 2 is 3. Okay, and then the 10 and x to the first, up 1 from 1 is 2. Okay, remember the derivative of x squared is x. So the integral of x is x squared, up 1. Okay, careful that constant doesn't go away. You're used to them going away. This time it gets the x. The derivative of negative 2x is negative 2. The integral of negative 2 is negative 2x. And then don't forget that, plus c. So right now it's c because I don't know anything more about it just yet, but we're about to. Let me clean this up a little bit. And now so far I've got that f of x equals x cubed. 10 over 2 would reduce to 5x squared minus 2x, but still plus a mystery c. Okay, here we go. They gave us one more piece of information. They said if I plugged in a negative 1 to this function, it should come out to equal a positive 9. So let's give that a try. Negative 1 cubed plus 5 times negative 1 squared minus 2 times negative 1 plus c. I still don't know c. He stays c. Okay, that's going to give me negative 1 plus 5 plus 2 plus c equals 9. So that would be 7, 6 plus c equals 9. So now, if I minus the 6 from both sides, c must equal 3. Be careful, that's not my answer, but I'm getting closer. So that means this guy right here with my new c filled in would be my final f of x cubed plus 5x squared minus 2x plus 3, because I just learned that my c is 3. Okay, so the final answer is not 3. The final answer is this function with the c filled in of the specific number 3. Because that way, if I plugged in a -1 with this right here, I should get a 9. F of 1, -1 is 9. Okay. All right, the dreaded word problem. Don't panic, we got this. Okay, because it says blah, blah, blah equation. Remember, those are the best ones. Okay, it gave me a derivative. This whole section was about integrals, so what do you think we're gonna do? Probably integrate it. Okay, now be careful, there's 3 parts. The first part wants c prime of 570. I've already got c prime, so that one I'm just gonna plug 570 into what they gave me. Okay, be careful to read those instructions. So when I do that, I get 12.6. This one was just making sure you're paying attention. Okay, then they want c of x. Okay, now this one wants the whole thing c of x with the constant filled in, just like we did on the blue one. So it did give us that one more piece of information. It said when they produced specifically 100 items, they got this cost. So this was a cost function. So it says when the x number of items was 100, the final cost was 7,285. Okay, just like up here, we got f of -1 equals 9. Same idea. All right, so here we go. First, I need to integrate. So the integral, I'll start it over here. This one's done. The integral of -0.02x plus 24 dx, okay, is how we're going to get my c of x. Scoot him, he's stretched. Okay. All right, so that would give me -0.02, and that's a single x, x to the first. So 1 higher than 1 is 2. Okay, this is the constant 24. It doesn't go away. For the integral, it gets an x. And then right now it's plus c. Okay, so this is my cost function so far, but I'm not done yet. Scoot this down just a little bit. We'll put our final answer up there. All right, so this could clean up just a little, and that'll help me out because -0.02 divided by 2 is -0.01. And then they told me that c of 100 equals 7,285. So let's go ahead and plug that in. 100 in place of those x's. Right now we still have plus the constant because I don't know the constant yet, but I'm about to figure it out because I know that this is going to be equal to 7,285. So I had to integrate first and then plug in, and that's going to give me, hang on, I got it worked out over here. So when you punch all of this part here, everything except the plus c into your calculator, you should get 2,300. Okay, so then when I subtract that over, the constant is the kind of crazy number of 4,985. Okay, now be careful, that's not the final answer. The final answer was this right here, the -0.01 x squared, just like right here, plus 24x, but then specifically with the c of 4,985. Okay, so the final answer is the function with the c plugged in. All right, and then the last part, just to make sure that we did it right, it wants us to plug 570 into our new cost function. So this time I go, there we go. Go and write out the numbers, 0, 1, 570 squared plus 24 times 570 plus that big 4,985. I'm sorry, so it's a 24. I don't know why that always happens. Okay. All right, so you punch all that in very carefully using all those parentheses, and you should get a final answer of 15,416. Okay, so be careful, don't let part A trick you. Part A was just plugging into what they gave you. Part B, we had to not only integrate, but also use that point to find the constant. And then after we got that figured out, part C was plugging in the number. Okay, guys, let me know any questions.